Hello again. In the last video, we saw that e to the x is its own derivative, but so what? Why do we care that e to the x is its own derivative? This video is just giving a bit of motivation to try to convince you that this is actually an important property that e to the x has, and not just a bit of mathematical trivia. So the example I will give is the outbreak of a disease. Let's look at a function whose input is the amount of time since the outbreak began, and whose output is the number of sick people. And we'll call, the name isn't so important, y equals f of x. But let's ask a question. How quickly is y growing? That's a very natural question to want the answer to in an epidemic. And we're asking about the derivative here. We're asking about dy dx. So every disease has what's called every infectious disease has what's called a basic reproductive ratio, which answers the question, how many people are going to get sick via contact from a sick person? That is to say, if I'm sick, how many people am I going to infect with my illness? So, because this is an average, it can be a decimal. For COVID, I believe it's about 3.3. And that's telling us something like this. Not exactly this, I'm simplifying a little, but it's telling us something like it. That the rate at which the epidemic is growing is 3.3 times the number of sick people. And something like this, where we have the derivative of y set equal to something involving y, is called a differential equation. Let's ask the question, what is the function y if dy dt equals 3.3 times y? Well, we now have the tools to see that it's y equals e to the power of 3.3 times t. the derivative of y using the chain rule is 3.3 times e to the 3.3t. E to the 3.3t is equal to y. So this function satisfies this equation. And in fact, this function is the only function that satisfies this equation up to a constant. If we put like 5 here, that would still. So, because of this, exponential functions show up in the study of disease dynamics. They show up for a similar reason in the study of population dynamics. If instead of asking, how many people will I make sick, I ask how many children will I have, we get the same kind of equation. So this is important. This derivative property causes the exponential function to show up in a lot of situations that you would not otherwise maybe expect the exponential function e to the x to show up in.